Jai Hind students, class 10, chapter 13, magnetic effects of electric current is actually divided into 5 parts broadly. The first part, magnetic field and field lines. What is magnetic field? The region around a magnet where the force of attraction or repulsion of a magnet can be detected is called as magnetic field. What are field lines? The magnetic field around a magnet can be detected by using a magnetic compass. The magnetic field lines are the path around a magnet along which the north pole of a magnetic compass needle tends to move. And it has 3 basic properties, fundamental properties. First, the magnetic field lines emerge at the north pole and merge at the south pole of the magnet. Second, the magnetic field lines are closer at poles where the magnetic field is strong. Third, the magnetic field lines do not intersect each other. Magnetic field due to a current carrying conductor is the second part of this chapter, where we will study the magnetic field due to a current carrying conductor, which is a straight current carrying conductor. Secondly, it is a loop, and thirdly, when the conductor is in the form of a coil. The second part and first subpart. You can see if there is a conductor passing through a A4 sheet and it carries current, then the magnetic compass will move around it in the form of the concentric circles. So around a current carrying straight conductor, the magnetic field is in the form of the concentric circles. And the direction, if the direction of the current is south to north, the deflection of the needle will be towards the west. The magnetic field around a current carrying conductor can be traced by using a compass. And the direction of magnetic field is given by right hand thumb rule, which was given by Maxwell's, so is also known as Maxwell's right hand thumb rule. It states, if you imagine the conductor in your right hand so that the thumb is in the direction of current, then the direction of wrapping of fingers gives the direction of magnetic field. So as shown by my right hand, if the current is upwards, up your table, then the direction of magnetic field will be anti-clockwise. And vice versa means if the direction of current is downwards, down to your table, then the direction of magnetic field will be clockwise. So this is, magnetic field is given by the direction of wrapping of fingers of the right hand in which you imagine the conductor in your hand. Then the magnetic field around a circular loop, again traced with the help of the compass, will be as shown in the diagram, which you can observe that it is in the form of the concentric circles around the conductor, and towards the centers the arc of the circles becomes larger and appears as straight line. The diagram is important. Its third subpart is magnetic field around due to a current in a solenoid or in a coil. A solenoid is a circular coil of wire in the shape of a cylinder. When current flows through a solenoid, it behaves like a bar magnet. The ends of the solenoid behaves like the north pole and the south pole of a magnet. The magnetic field produced by a solenoid is similar to the magnetic field produced by the bar magnet. The strength of magnetic field depends upon the strength of the current and the number of coils. So what are the factors on which the magnetic field depends on? Is the current and its direction, and also the number of turns in the coil. So this is how the second part of this chapter is over. So first part will be the magnetic field and field lines, and the second part will be the magnetic field around a straight current carrying conductor, a loop and a solenoid. So now we are for the third part of this chapter. Again a diagram to explain what is solenoid and how a solenoid behaves like a bar magnet. that if you bring a bar magnet, south pole, near the solenoid and that end behaves like a north pole, the south pole will be attracted. So this is how the solenoid behaves like a bar magnet. Then what is electromagnet? If you put a soft iron core in the solenoid coil, then it becomes magnetized, and this kind of a magnet is called as electromagnet. The third part of this chapter, force on a current carrying conductor in a magnetic field. As shown in the diagram, there is a magnet whose north pole is here, south pole is here. So the magnetic field is from north to south. And if there is a conductor placed perpendicular to the magnetic field, as soon as the current is on, the conductor will move perpendicular to perpendicular to the current as well as magnetic field. So this conductor will either move out or this conductor will move either or in. And that direction of force or that direction of motion is given by Fleming's left hand rule, which states if you stretch the thumb, the forefinger and the middle finger of your left hand such that the magnetic field is represented by the forefinger, the current in the conductor by the central finger, then thumb gives the direction of motion. So in our diagram, the magnetic field is up, the current is towards the door, the conductor will move out of the magnet. And this is what is shown in the diagram. So there is a force on a current carrying conductor placed in the magnetic field. If the direction of the current is reversed, the direction of motion will also be reversed. Which rule says so? The Fleming's left hand rule. So this is the diagram, this is the demo which I gave and is shown in the diagram. What is electromagnetic induction is the fourth part of this chapter, and what is that is, if there is a conductor moved in the magnetic field, the current is induced in the conductor, this effect is called as electromagnetic induction, also known as EMI. And what are the two activities for this? First, motion of a magnet with respect to the coil produces the induced current. As shown in the diagram, there is a conductor moved in and out in the coil, the current is produced. And that current produced can be seen, can be detected by the galvanometer connected to the coil. Then the second activity for EMI is that there are two coils. One coil is connected to the battery or the cell and the other coil is connected to the galvanometer. As soon as the switch is on in the first coil, the current is on and there is a electromagnetic induction seen in coil 2, and thus the induced current in coil 2, and the presence of the induced current is shown by the deflection in the galvanometer. Now as soon as we switch off the key in the coil 1, the current falls down to 0, and at that point of time in coil 2, the induced current is in the opposite direction, which can again be detected by the galvanometer. Now Fleming's right hand rule is the rule which will give the direction of the induced current in the coil or in the conductor, which states if you stretch the thumb, the forefinger and the middle finger of your right hand such that the forefinger is in the direction of magnetic field, the thumb is in the direction of motion of conductor, the central finger gives the direction of induced current in the conductor. Then this is the principle for electric generator also, which produces alternating current known as AC. Here the direction of current keeps changing with the regular interval of time, rather keeps reversing with the regular interval of time, and this is known as alternating current. Now in India, the alternating current frequency is 50 Hz, 50 Hz, and the direction of change is of course 1 upon hundredths of a second. Now to produce DC by the generator, the split rings are to be used, and that split ring will produce, using the split ring in the generator will produce DC. What is DC? Is the direct current where the direction of current does not change. It is a unidirectional current. The graphs for DC and AC are shown in the diagram. First graph is for DC, the direction of current does not change. The second diagram is for the alternating current, where the direction of current keeps reversing after the regular interval of time. The last part, fifth part, as I mentioned in the beginning of the chapter, is the domestic electric circuit. What are the parts of domestic electric circuit? First, how many wires are there? 2. And there is a third wire also, which is known as earth wire. Now these 3 wires run parallel to each other. There is a color code for each wire. Live wire red, neutral wire black, and the earth wire is green in color. Now fuse is connected in the live wire, then it passes through the electric meter, and then there are different extensions for the live and the neutral wire supplied. Now for the one room supply, there is one live wire and one neutral wire running parallel to each other, and each gadget will be connected to one terminal. One terminal of the gadget will be connected to live wire, the other will be connected to the neutral wire. But if the gadget is of heavy power, then there would be third terminal of which will be connected to the earth wire. Then what is the function of the earth wire is, any leakage of current, any excessive current is passed to the earth through the earth wire, and the current flows in a circular manner from live wire to the neutral wire, and the plug on gadget will keep functioning accordingly. There are 2 types of lines for the domestic circuits. One is of 5 ampere rating, another is 15 ampere rating for the heavy gadgets. The appliances having metallic body like electric iron, refrigerator, etc., their metallic body is connected to the earth wire, so that if there is a leakage of current, it passes to the earth and prevents the electric shock. So how many wires are running parallel to each other? 3. Live, neutral and earth. Then what is the electric fuse? What is its function? That it is a safety device and it prevents the electric wiring. As you know, why? Because it has a high resistance and has a low melting point. If excess current flows through the circuit in any circumstance, the fuse wire will melt and will break the circuit. Fuse wire is made of a metal or an alloy of metals like lead, tin, aluminium and copper. Fuse wire is connected in series of the live wire. Now what can be the different reasons for the excessive current to be flowing in the circuit? One, it can be overloading. Another, it can be short circuiting. What is overloading? It is caused due to the increase in voltage, or if the live wire and the neutral wire comes in contact. When the live and the neutral wire comes in contact with each other, the resistance of the circuit tends to be 0, and that increases the current, due to which the heat will be produced according to the Joule's heating effect of current. H is equal to I square RT. I increases, R tends to be 0. Lots of amount of heat is produced, and that results in overheating of wires and can cause the damage to the circuit and the appliances. Before the damage takes place, the fuse melts and prevents the circuit damaging. Short circuiting is caused again when the live and the neutral wire comes in contact with each other, and again the current increases and the overheating may cause spark, fire and damage to the circuit. Then what is the difference between the overloading and short circuiting? Overloading takes place due to the many gadgets connected to one socket. Each one of them keep drawing their own current, and the current increases because of the overloading of a socket. And short circuiting takes place when the live and the neutral wire comes in contact of each other. Why? Because of maybe the poor insulation, maybe any defect in the gadget. Thus, all 5 parts of this chapter. Thank you.